Hello, 8th grade math students. Mr. Lawrence here. It's so nice to see you. Hopefully, well, I can't really see you, but you know what I mean. Anyway, hopefully it's nice to hear me. I hope that you're taking advantage of getting the work done because it looks like we may not be in school for quite a while. Maybe not till the fall. I don't know. I'm not the governor. I can't predict that. But you definitely want to stay up on this material. One, it's going to help you in algebra tremendously. Two, if we do go back this year, well, the kids who have been staying up on it, they're going to be fine. Now, don't know if you're aware of this, but today I helped Hannah Friedline on something called Google Meet. And we could do a little video. It's almost like a Skype kind of situation. And I was able to show her what I was doing in a problem, which sometimes works better than typing responses back and forth in a chat. So keep that in mind. Remember, my next office hours will be 10 to 11, Monday through Friday this week. And then we'll take a week off, and then we'll start up again the following week. All right, so let's get down to the video. It says one pencil and one marker costs $1.50. Two pencils and one marker costs $2. What are the cost of one pencil and the cost of one marker? Well, to do a problem like this, I'm going to need to write what's called a system of linear equations. It's when I have more than one equation at a time. It's not unlike the lemonade problem we did with Gnor and Garrett, in the two different classes. It's very similar, except in these situations, I'm going to define my variables, and I'm going to say let x equal the cost of a pencil. Okay. How do I know to do that? Well, it says how much does a pencil cost? So I have to define one of my variables to be the cost of the pencil. And then I'm going to let y equal the cost of a marker. Okay? And again, how do I know? Because it says what's the cost of the marker. It wouldn't matter if you made y the cost of a pencil and x the cost of a marker. You'll still get the same solution when you go to graph. Well, I'm going to need two equations. My first one is going to be the cost of a pencil, one pencil, which is x, plus one marker, actually the cost of a marker, which is y, and that's going to equal $1.50, okay, or $1.50. The other equation is going to be two pencils, so I'm going to have 2x, cost of two pencils, plus one marker, the cost of one marker, which is y, because I don't know, and that's going to equal 2, or $2. Okay? Now that I have that, I can go ahead and graph these equations. I'm going to bring them on down here. Oh no, I got part of the equation. That's no good. Let me go back and get the x. There we go. And then let me get this one here. All right. And so notice I have the cost of markers on the y-axis and the cost of the pencils on the x-axis. Well, first I need to get my variables alone. In other words, get my y alone. I have to get them in slope-intercept form. So with the green one, I'm going to subtract x from both sides. And when I do that, I will get y equals negative x plus 1.5, or $1.50. I'm ready to graph. I know my y-intercept is 1.5, right? So I'm going to go to 1.5, and then my slope is -1, or -1 over 1. So I'm going to rise -1. Now be careful, that doesn't mean go down to 1. That doesn't mean go down one spot. That means I have to go down a full 1. How many does it take to get to 1? Well, 1, 2, 3, 4. So I'm actually going to rise -4, like that, down to here, and then I'm going to run 1, which is here. Okay, now I can't do it again because I'm out of room, but if you look, I did this, right? That is the same as doing -2 over 2, or -1 over 1. So I could have gone like this. Watch this. They're going to land on the same exact line. Look at that. I hit the point. I was cautious at first, because I wanted to make sure I was counting by what the graph was counting, but it turned out it didn't matter. Now I'm not going to draw a full-blown line on this one, because as soon as I cross the x-axis and y-axis, I end up dealing with negative amounts. Can a pencil or a marker cost a negative amount of money? Of course not. That's why I'm not going to worry about it. Okay? So I have that right there. Okay. Now, when I do my blue one, by the way, oh, never mind. I won't go into that right now. I'm going to get my y-intercept form of the blue equation. So I'm going to subtract 2x from both sides. And when I do that, I'm going to get y equals negative 2x plus 2. What just happened there? Oh no. Got some serious lag going on. Plus 2. There we go. I don't know what just happened. Just a little lag. It's okay. Everybody stay calm. Quit panicking. All right. So I'm going to put my y-intercept at 2, and my slope is negative 2 over 1, right? Negative 2 over 1. So I can use the same logic I did last time and go down 1, 2, and over 1, and down 2 and over 1. Oh, look at that. I found out where the two lines cross. That is important. To solve a system, you want to know where the two lines cross. Did you write that down? To solve a system means to find out where the two lines cross. And actually, it's not where the lines cross, because we don't have to be limited to lines. We're going to be solving systems of linear equations here in this class, but when you get up into some higher classes, you're going to solve more complicated systems. They might have a quadratic and a linear, finding out where they cross. All right, I know you don't know what a quadratic looks like, but I just wanted to plant that seed. So it looks like they're intersecting here. Well, what are the coordinates of that point? Well, it looks like I'm going to get a half, and I chose not to write that as a fraction. You'll see why in a minute. And then 1, right? And remember, the x-coordinate is the cost of the pencils. Guess how much a pencil costs? Look at that. A pencil costs 50 cents. Yeah, and the y-coordinate is the cost of the markers. Well, that means that a marker costs $1. Now let's go back and check and see if it works. Okay, so we said 50 cents for a marker and $1 for a pencil. Well, it says 1 pencil, so that would be $1 plus 1 marker, 50 cents. 1 plus 50 cents would be $1.50. Bam! 2 pencils. Oh, did I do that backwards? I did that backwards, didn't I? A marker costs $1. Oh, silly Mr. Lawrence. I got so excited, so proud of myself. All right, it's not going to let me fix it, so I'll just have to do a little erasing, no problem. Okay, so a pencil costs 50 cents, right? And a marker costs $1, and it still get $1.50. Okay, 2 pencils would cost $1, wouldn't they? Because 2 times 50 cents, like 2 times 50 cents, right? That would equal $1. Plus 1 marker, which costs $1, and 1 plus 1 is, you guessed it, $2. Okay, that's a way to solve a system by graphing. Now let's go ahead and take a look at some more of the digits here. All right, I'm going to jump on over here. Okay. And they want us to determine whether these following represent a system of linear equations. Well, first of all, we have to have an equation. To have a system, we need 2 or more linear equations. Well, this first one is only an expression, right? 14x minus 24, so it is not a system of linear equations. This one here, 2.5x minus 3 3/4 y equals 5.5. Well, that's an equation, but it's only one equation. It is not a system. Here we have y equals 1.5x and y equals 2x minus 1. They're both linear. They're both equations. There's 2 of them. It's a system. Yay! Okay. X equals 2. Do you remember what kind of line that is? It's vertical. Yeah. Did you catch that? It's vertical. Okay. And this is a horizontal line, and it is a system. By the way, I know the solution to that system. I do. It's really easy. They intersect at the point 2, -3. Yeah, I wonder how I got that. All right, 5x minus 7y, no equation, so therefore it can't be a system of equations. 2x plus 3y equals 6, it's an equation, but it's not a system. There's only one of them. Y equals x, which literally means y is the same as x. So if you say x is 3, y is 3. If x is -17, then y is -17. If x is porcupine, y is porcupine. Yeah, no fooling. And then y equals x plus 5. That's two linear equations. It's a system. Dun, 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 dun. All right, moving right along. And we're loading. We're loading. We're still loading. There we go. Okay, is 2, 4 a solution of each system of equation? Explain your reasoning. So let me see here. I don't know if I have these written down. We got 2x and 6x minus 8. So let me see here. I had the equation y equals 2x and y equals 6x minus 8. And they want to know, inquiring minds want to know if 2, 4 is a solution. Is 2, 4 a solution to the system? Well, there's a couple ways to do this. One would be to graph it, okay, and see if they cross at 2, 4. I'm not going to do that, but it's not a stupid thing. Remember, this is the x-coordinate, and this is the y-coordinate. If this point, 2, 4, is a solution to this system, it'll give me a true statement for both problems. When I put x, 2 in for x, I'll get 4 out for y. So let's see if that works. So I'm going to come over here and do y equals 2, and I'm going to substitute the 2 from the point in. Well, 2 times 2 is 4, so y equals 4. So ding, 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 it worked for the first equation. All right, now I'm going to go to the second equation, and I'm going to go y equals 6, and I'm going to put, 2 in, and then I've got to do minus 8. So that means that y is going to equal, 6 times 2 is 12, minus 8, y equals 4. Yes, it is a system. It gave a true statement for both equations, right? I came up with the correct y-coordinate. Now they have another system they wanted me to check, and I suspect it's not going to be a solution, but let's check it anyway. Let's go see what that system was. X minus y equals -1, so that is x minus y equals -1. We're still testing the point 2, 4, by the way. Okay, and then the other equation is 2x minus y equals +1. So that'll be 2x minus y equals +1. Now in this one, if you want, you can get y alone, but you don't have to do all that work. You can substitute both in and see if they equal -2. So let's try it that way. So I'm going to have x's value, which is 2, right? And then I'm going to subtract y's value, which is 4, and I'm going to do the math on that and see if indeed I get a true statement. It should equal -2 if I'm right. Well, there's nothing really to simplify. 2 minus 4 is -2. There you go. It worked. But got to try it on both of them. So I'm going to have 2, and then I'm going to substitute in 2. y2, because that's the x-coordinate. Then I'm going to subtract y's value. I don't know if you notice, I always use parentheses when I substitute in. And I'm going to see if that equals 1. Does that equal 1? Well, 2 times 2 is 4. 4 minus 4 equals 0. It does not equal. It doesn't work for this one. So no, it's not a solution to the system. Okay, I would have had to have gotten 4 out for it to work. So this one doesn't work, frowny face. Okay, it was only a solution to the first system. Okay, doing this problem the same way. You're going to put 3 in for x. Well, 3 times 3 is 9. And then put -4 in for y. So I have 9 minus 4, which is 5. It worked. Let's check the bottom one. I'm going to have 3 minus -4. Uh-oh, a double negative. 3 minus -4. Let me see. Is it going to let me write on here? It's not going to let me write on here. Okay. Well, that next one looks like 3 minus -4. Well, those two change to positive, and 3 plus 4 is 7, and that's what it's supposed to equal. So yes, that one is a solution. Okay. One more type of problem I want to go over, and then that'll be it for the video. And we're loading. We're loading. All right, here we go. All right, there's this long video here about some alligators, and they show you a cool thing, but I am going to skip it. No, I'm not. It's not going to let me. All right. Oh, there we go. Good. Okay. Now, they show you in this table, alligator 1 has an initial weight of 4 pounds. Well, the initial weight, doesn't that sound like the y-intercept, right? Like b, right? Okay, and a rate of growth. Rate of growth, that's just another name for the slope. 1.5 pounds per month. But you know what I'm going to do? I'm going to write an equation. I got an initial weight of 4 pounds and a growth rate of 1.5 pounds per month. So for the first alligator, I've got the equation y equals 1.5x plus 4. Okay, y is the total pounds, total weight of the alligator. And x is, I believe we're in months, the number of months that have gone by. Okay? And then for the other alligator, it's starting at 6 pounds and it's growing at 1 pound per month. So the other alligator is growing at a rate of 1 pound per month, but it started at 6 pounds. Now, I think all they did was ask us to write a system. We just did. We just wrote 2 equations. Okay? If you ever wanted to figure out when the 2 alligators weighed the same amount, we could graph them both. I'll tell you what, let's go to Desmos and do that. All right, so let me get out Desmos up here. And let's see here. Let's see. We need y equals 1.5x plus 4. That's the first equation. And then y equals 1x plus 6 is the second equation. And let's see. Scrolling, it looks like that after 4 months, both alligators will weigh 10 pounds right there. That would be the system. Okay? If those rates continue, the one that started at 4 pounds will be heavier the first 4 months of their lives, assuming they were born the same day. And at 4 months, they'll weigh the same amount. Then after 4 months, the one that started at, oh, I said that backwards. The first 4 months, the one that started at 6 pounds would weigh more. At 4 months, they'd have equal weight of 10 pounds. And then after 4 months, the one that started off lighter would end up actually being heavier because it's growing at a faster rate. Now, that wouldn't continue forever because things stop growing at some point. Okay, so that's the video, ladies and gentlemen. I hope to see you in my office hours. Talk to you later. Bye-bye.